Saw some pictures drawn, not a lot though, which is okay. I'm not saying you have to draw the pictures. If on a problem like this where I said to solve, if you would only have to draw pictures if it was like some of those earlier problems we had which said draw the reference angles or draw the angles in their proper quadrants, or something where I was saying draw the sketch, but probably not going to do that much. Our next quiz is going to be Friday. That quiz is going to have some identities on it, and it's going to have these equations on it, basically those two things. So we're going to spend a lot of time now. We don't have class Wednesday, so we're going to spend more time today adding to what we can do with these equations. Tomorrow, probably get into a few story problems a little bit with it, show what we can do with those. Then we'll do more of that tomorrow. Probably Thursday will be about reviewing that and bringing back the identities and working on some identities, stuff like that. And then Friday's a quiz. And it'll be two parts, before lunch, after lunch. The before lunch will be no calculator, and then some of the calculator ones after. So where does cosine equal -1/2? So, right, cosine is negative in the second, third quadrant. So to me, if you're going to draw a picture, it would be like that. Then, of course, it's just knowing your unit circle, or maybe just remembering that, okay, -1/2 would be here. This would be √3/2. And so that's going to be a 60-degree reference angle or a pi-thirds reference angle. So, again, memorizing the unit circle or knowing your triangles and the idea of reference angles, that's the key. And so if if the directions said go here, then we would just do two answers. This one would be what? 2 pi-thirds, and then the other one would be 4 pi-thirds. And so you would stop, and that would be your answer. If there are no other directions, if it just says solve, then you can assume that means for all solutions. Now, it'll probably be specific and say all solutions. Then in that case, we would do 2 pi-thirds plus 2 pi n, and we would do 4 pi-thirds plus 2 pi n. Remember, the 2 pi n just means one time around the circle, either backwards or forwards. So this one, we could keep coming around, coming around, coming around. That would give us all of those. And then the one in the third quadrant, we would have to write out as well. Okay? Because they're not equally spaced apart. They're not straight across from each other. If we go to the next one, cotangent, where does cotangent equal 1? That would be at a reference angle of pi fourths. Because just like tangent, now the first thing you'd probably do is do that. Whenever you have cotangent, cosecant, or secant, you probably should flip them first so you can get them in terms of sine, cosine, and tangent. But in this case, it's the same. Doesn't matter. And so this is when we have √2/2 and √2/2. That's when tangent is 1. So that's going to be pi fourths, and that's the first and third quadrant. So we got pi fourths, and we got 5 pi fourths. So if you were just giving those two answers, you would have that. Or if you were going to do all solutions, what would you say? Pi fourths plus pi n, and that would take care of all of them. That would take care of all of them. And I don't want you to put pi, you would get most of the points. I would probably subtract 1, though, if you had pi fourths plus 2 pi n and 5 pi fourths plus 2 pi n. Again, it's a little bit unnecessary. I want the simplest version we can write, which would be that. Okay? All right. Now, number 3 is not one that we've done. That's what we're going to focus a little more on today. But I was hoping that it would be fairly obvious what to do. Maybe not. What did you come up with? What did you do?
Subtracted sine to the left side.
Okay. That could be fine. Or add this and subtract that, but that's fine. So you get √2 equals what? -2 sine x? Like that. And then what?
Divide -2 out.
Divide -2 to both sides and turn it in to that. And that is exactly right. Now, why did I... What did I do wrong?
It should be negative.
Yeah, right here. That's negative. Oh, gosh. Boy, I botched that, didn't I? Well, I was trying to show you common mistakes that can be made.
Yeah.
All right. So, yes, that should be negative there, right? Because what I did was I added the sine x over here and then subtract the √2 to that side is the way I was showing it. So that'd be negative. and then divide by the 2. Okay, so that brings up the next step in our learning curve on doing these is when we want to solve one of these equations, we want to isolate the trig function, a single trig function on one side of the equation by itself. It's kind of like in algebra class, the goal was get x by itself. For us, the goal is get the trig function by itself. Get the trig function by itself. So what we want to do is turn it into what we practiced today. If you look at those two worksheets today, they all have the trig function by themselves and then a number on the other side. So if we have one that's not that way, we want to get it that way. And you do all your normal algebra rules, add to both sides, square root. We might factor. There's all kinds of things that may come into play. We're going to practice those today. All right, so now we're just doing this. Well, that's going to be down in these two quadrants. That's going to be a pi force reference because that's where sine is negative. So that's going to be 5 pi force and 7 pi force for our two answers, or each one of those with a plus 2 pi n tacked on if you're doing all solutions. Okay, so identify and get the trig function by itself is the goal there. Okay, and if it's a no calculator, we should come up with one of our nice angles, right? Either one of our quadrant ones, like pi halves or pi, or we should get root 2 over 2 or root 3 over 2 or 1/2 and so forth. Okay, all right. Secant. So what we had said last time here is if you have secant, the way to do it on your calculator is to do secant and cosine. So this is like saying cosine x is equal to -1 over 3.79. Okay, so to solve that on your calculator, we do inverse cosine of that. Did you guys, do you agree with that? 105.30 degrees. Okay, inverse cosine -1 over 3.79. Now it's not surprising that it gives it to us in the second quadrant because that's where cosine is negative. But we've got to do more than that, right? Understand that when we go to our calculator to solve a trig equation, it's only going to give one answer. That's going to give us our reference angle. It's up to you then to draw your other one. Okay? So whenever we use our calculator, and why does it give us one? Because it's programmed with the inverse function. One number in means one number out. And we already learned earlier in this chapter how cosine is restricted to the first and second quadrants. Inverse cosine, positives will be here, negatives will be in the second. With sine and tangent, they're going to be either first or fourth quadrant. All that the calculator is doing for you is giving you the reference angle. So this is going to be one of our answers. But what will this one be? We need to know that reference angle. How do we get it? No. We need to figure out this angle here because this angle here is going to be the same as that there. So we need to do 180 minus 105.3, which is 74.70 or, okay. It's probably good not to round. I mean, in other words, when we do the 180 minus, it's probably better to bring back that previous answer, but it's not huge. I want your final answer accurate to 2 decimal places. So that means this is going to be 74.70. So inverse cosine is the only one we're going to have this problem, okay? Because if this was, everybody do inverse sine on your calculator right now. Do inverse sine of that same number. Do inverse sine of this same number for me. What do you get? Negative 15 point, okay? Well, that's going to be right down here. Negative, well, that is the reference angle. Negative 15 point whatever, right? So that'll be the same reference angle over here, 15. So you do 180 plus that. So that basically gives you the reference angle. And if it's positive, of course, it would give you a first quadrant, and that'd be your reference angle. Same thing with tangent. Tangent's going to give you either a positive angle in the first quadrant, or it's going to give you a negative angle in the fourth quadrant. Again, that will be your reference angle. The only one that doesn't is cosine. when you do second cosine or inverse cosine, if it's negative, it's going to give you a obtuse angle, a second quadrant angle. So it's going to be up to you to subtract from 180 to get that reference. Okay, so my answers are 105.30, and what's 180 plus that? 254.70 would be my two answers. Okay, so a little bit of extra work there. When you get a cosine answer on your calculator, you've got to find that reference angle to help you get the third quadrant one. Okay, now if we were supposed to find all solutions here, we would go 105, since these are not straight across from each other, 105.30 plus 360 n, and 254.70 plus 360 n. Do not put a pi on there. Okay, remember 2 pi and 360 are the same, so it's either 2 pi n or it's 360 n. Don't put, and also don't put 105.30 plus 2 pi n. That's not good. Don't mix degrees with radians, right? So if we're doing all solutions with our calculator, it's 360. So we add 360, add 360, takes us around or takes us back. Okay? All right. All right. Now, and I guess I should say, maybe this is obvious to you. What did the calculator give you on that one? Negative what? 15 point something? Negative 15.30. So this is, now to be honest, I wouldn't even put a negative on it when I drew it in here. What would be my answers though for this? Would negative 15.30 be an answer? No, because the directions would have been that your answer has to be between 0 and 360. Negative 15.30 is not between 0 and 360. Okay? Now, this is a little bit of a technicality. I probably would let you off the hook on this one, but if it says 0 to 360, you need to do 180 plus 15, so that'd be 195.30 would be one of your answers. And then how do you get this one? 360 minus 15.0, so that would be 340, 344.70, right? Those would be your two answers. So the calculator gave you the negative 15.30 when you did your inverse cosine or inverse sine, but you would need to draw them and you would need to give your answer between here and here. Now, if it said all solutions, it would not be wrong to do this. That actually would be okay because you're giving all of the answers. So negative 15.30 plus 360, that'd give you this one, plus 360, plus 360, plus 360. That would actually be okay. Okay, now I'm guessing most of you wouldn't. You would probably give these and do plus 360 in, and that's fine also. That's fine also. Okay, but when it says between 0 and 360, the two answers have to be between 0 and 360. Okay, so the goal here was to try to really get to understand, once we have the trig function by itself, how we find these answers. So now our work's going to focus on how do we get the trig function by itself. But that's mostly algebra, so that part should be okay. Let's just read through the answers here real quick. I think I've got it. Maybe I do. I think I have them in my notes here. What did these say? Intro. What did it say at the top? Intro trig functions. Where are the answers? Okay, well, we'll do this by democracy, democratic. Whoever agrees with the most answers will win. I could have sworn I had this. All right. Okay, on the one without the calculator, okay, number one is what? Shout it out, quick.
5 pi 6, 11
5 pi 6, pi 6, 11 pi 6?
5.
Yes.
5 pi 6, 11 pi 6.
Yes.
Number two.
2 pi thirds, 4 pi thirds.
I agree.
Number three.
No solution.
No solution. Number four.
0 and pi.
0 and pi. Number five.
0.
Do we need to talk about 5 and 6 and
And
7
7.
kind of?
Yeah.
And 8? Okay, what do you got for 5?
0, 2 pi thirds, 4 pi thirds, 2 pi.
Okay. Anybody disagree? Must be right. Number 6. Pi halves.
I have it.
Mark that one. Number 7.
Negative pi 6, negative 7 pi 6.
We got negative 4 pi thirds.
Well, they can't be negative because we got to be between 0 and 2 pi. It should be pi thirds and 2 pi thirds. It should be pi thirds and 2 pi thirds. Okay, 6 and 7 we'll look at. Okay, number 8.
3 pi 8. 3 pi halves.
I think 3 pi halves and 5 pi halves. No, 5 pi halves?
Okay, yeah, we need.
Okay, we'll have to look at it.
5 pi halves is over.
Yeah, that's too big. That's over. Okay. Number 9. Pi fourths plus 2 pi n. 5 pi fourths plus 2 pi n. No, 3 pi fourths, I mean.
Yeah.
3 pi fourths plus 2 pi n. Okay, number 10. Pi halves
Plus 2 pi.
plus 2 pi n. Number 11.
2 pi thirds plus pi n.
2 pi thirds plus pi n, because this would be in the second and the fourth quadrants, straight across from each other. 2 pi thirds plus pi n. Number 12.
5 pi 6 plus 2 pi n.
5 pi 6 plus 2 pi n, and 7 pi 6 plus 2 pi n. Okay, calculator ones I don't even want to get into. All right, because that's easy. Okay, but I'll get the answer. I can have a way of getting the answer. So if you really want to check yours, we can do that. Okay, so let's talk about those multiple, what I call the multiple angle problems. So when you have a 3 theta, or you have a theta over 3, or you have a theta over 2, okay, those multiple, when you have something other than just x on the inside, okay? Now, we deal with that at the very end of the problem, just so you understand, okay? We deal with that at the end of the problem. So let's pull this one up. I think we did this one the other day. So let's just do this one. Now, what I want to do with this is show you graphically why this makes sense. So normally, so let's say that this one is saying that x has to be between 0 and 2 pi, like our normal problems do. Okay, normally, how many answers do we have when it says this? 2. Sometimes only 1, if you get one like sine, like the one we had sine, if you get sine equals 1, right? Well, sine only equals 1 time at pi halves, right? That's the only time sine is 1. So sometimes you get 1 answer, but most of the time 2 answers, okay? But in this one, we got 4 answers. Why would we get 4 answers? Well, here's how we worked it the other day. I think it was the same problem. First of all, what do we do with this negative? With sine, we can kick it out because it's an odd function. We can do that with tangent also. With cosine, what would happen to that negative? It would just disappear because it's an even function, and so cosine of a negative 2x is the same as cosine of 2x. We could just drop it out and it'd be the same thing, okay, because it's an even function. So on this one, what I would do is take out the negative, okay, I just think that's something we should do every time, and then we get that. Now, could we still do it without doing that? Yeah, I think we could, and it would, but then we'd have to really manipulate our answers later on. I think we're better off doing it this way. Plus, I think it's just important to know that even odd function thing, and this is a good way to practice. So, we got that. Okay, now again, keep in mind, we're not taking out that negative like a factoring out thing, right? You got to understand, with cosine, that negative would just disappear. With sine and tangent, that negative pulls out. It's because of even odd functions, okay? All right, well, so now we kind of ignore the 2x for a minute. We just kind of ignore the 2x here, and we just ask ourselves, where would sine be this? Well, that would be where? down here and down here, right? And what's the reference? Pi. Well, the easy one to remember is sine. When sine is 1/2, isn't that always pi 6? I mean, that's what I always remember. Sine of pi 6 is 1/2. So when I see root 3 over 2, I know it's going to be pi thirds, okay? So the reference is going to be pi thirds and pi thirds. Now, maybe you're thinking of unit circle and you're doing it that way. That's fine, whatever, okay? But this is going to be 4 pi thirds and 5 pi thirds, right? Are my two answers. But now what we have to do, instead of writing x equals, right, when we write those down, instead of writing x equals 5 pi fourths and 7 pi fourths or whatever, we have to write 2x equals 4 pi thirds and 5 pi thirds. Okay? Now, this is where we also kick into, okay, wait a minute, there's something extra I have to do here when I've got this 2x, and it has to do with this up here. Okay, if x is going to be between 0 and 2 pi, 2x has to be between 0 and 4 pi. In other words, just think of you're taking this inequality right up here, you're taking your original inequality, and you're multiplying everything by 2. You multiply the left by 2, the middle by 2, and the right by 2, which is a perfectly legal thing to do. You did it in algebra class when you were trying to solve these compound inequalities. You multiply everything by 2. So now 2x has to be between 0 and 4 pi. What that means is you go around twice. 0 and 4 pi, you go around twice. So we got 4 pi thirds, we got 5 pi thirds, now I got to go around again. So this would be 6 pi thirds, 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, or just add 6 pi thirds onto this one, right? 4 pi thirds, and then add on another 2 pi, another time around. So that's going to be 10 pi thirds, and then this one's going to be 11 pi thirds, okay? That's going to be your 5 pi thirds plus another time around, plus another 2 pi. So that'd be 5 pi thirds plus 6 pi thirds is 11 pi thirds. Okay, I have 4 answers. Now we divide everything by 2. Now we divide everything by 2, which makes a bottom number what? 6. Makes a bottom number 6. So this becomes 4 pi 6. This becomes 5 pi 6. This becomes 10 pi 6. And this becomes 11 pi 6. Now you shouldn't leave your answers like that because this should reduce to 2 pi thirds. And this should reduce to 5 pi thirds. So that one, that one, that one, and that one are our 4 answers. Now, that's how I showed you to do it on Friday. Okay? So we have that multiple angle on the inside. We kind of ignore it at first. We get the trig function by itself. We figure out what quadrants we're in for whatever values over here. We get our reference angles just like we always do. We write them down just like we always do. But instead of writing x equals, we have to write 2x equals. So now, since x is between 0 and 2 pi, 2x is between 0 and 4 pi. So we got to go around twice. We get 4 answers. Then we divide everything by 2, and then we get what x is. And now we notice that all of those are between 0 and 2 pi, right? Even this last one is between 0 and 2 pi. Now, let's talk about why that should make sense. What does this do to the graph? Makes the period what? Makes the period pi, right? So, remember, don't forget about graphs. Okay? Look at the example I gave you the other day. Right here. From 0 to 2 pi. Here's sine x, here's a half. Where does sine x equal a half? It's where these two cross. Right there and right there. Now here's 2 pi right here, right? So between 0 and 2 pi, how many times do these two graphs cross? Twice. Pi 6 and 5 pi 6. That's why there's 2 answers. But now, what happens when you squeeze the graph? How many times is that graph going to go up and down? More. That graph is now going to cross that line more than once. So the problem we just did was this problem right here. So here's 0. Here's 2 pi. Look at this. And it's negative 2x, right? So it goes down first. So look at this. 1, 2 full cycles. How many from 0 to 2 pi? How many times does it cross? 1, 2, 3, 4 times. It makes sense that if you compress the graph and see how many times it equals this, it's going to hit more times. What happens if you stretch the graph this way? We're going to probably hit less times. Okay, so look at those answers. Aren't those the 4 answers we just had? 2 pi thirds, 5 pi 6, 5 pi thirds, 11 pi 6. So to help you conceptually get it, that's what's going on when we do these equations. Okay, all right. So what was one of those you guys had in the homework?
3 over 6.
So it was, what was it? 1 equals 3. No, we didn't have a question on that. Root 3 over 3 equals tangent of theta over 3. Right? Okay, so pretend that's flipped around, doesn't matter. So where's root 3 over 3? Well, I always think of that as root 3. I always think of that as 1 over root 3. Remember I said that the other day? Root 3 over 3 is like, now maybe you're memorizing it a different way, that's fine, but you got to know it. You just got to know it. But to me, I think of root 3 over 3 as 1 over root 3, which to me is 1/2 over root 3 over 2, because the 2's cancel, and tangent, of course, is sine over cosine. So doing tangent root 3 over 3 to me is like doing sine is 1/2, which is a reference angle of what? Pi 6. So this one is going to be a pi 6 reference angle, and it's going to be in this quadrant, and what other quadrant? The third quadrant, because this is tangent, and tangent is positive in the first and third quadrants. Okay? So, and the directions here were what? Between 0 and 2 pi, right? So we're looking between 0 and 2 pi. All right. So that means theta over 3 is going to be pi 6. What's this one? 7 pi 6. So, right? We just do it like we normally would. Now we have to deal with this theta over 3. Okay, so if theta is going to be between 0 and 2 pi, what's theta over 3 going to be between? 0 and 2 pi thirds. If theta is going to be between 0 and 2 pi, then theta over 3, you're going to divide everything by 3. And you're going to have 0 and 2 pi thirds. Now, where is 2 pi thirds? 2 pi thirds is over here somewhere, right? So what's that mean? We only want to look from here to here. So 7 pi 6, out of there. 7 pi 6 is not where we want to look. We want to look, theta over 3 can only be between 0 and 2 pi thirds. So we're only going to look from there to there, 7 pi 6 and 2 pi. Because what does 1/3 theta do? It stretches the graph. And so now there's only going to be one answer. Now what do we do to get our theta, though, to finish this? We times by 3. So that'd be 3 pi over 6, which is pi halves. And that's why the answer ended up being pi halves. Okay, so we do everything the same as normal. We ignore that theta over 3 at first. We figure out what our two angles would be normally. And then we say, okay, but where are we supposed to look for theta over 3? Okay, and we only look from, in this case, 0 to 2 pi thirds. We only have one that's drawn in that region. That's the only one we use. Okay, and again, think about it. If you use 7 pi 6 and then you times by 3, that'd be 21 pi 6, which would be 7 pi halves. And that's what we were saying. 7 pi halves is too big. That's outside of 2 pi. Okay, so 7 pi halves can't be one of our answers. And that's another way I've seen people do it, is they do both of them and then they times by 3 and then they say, whoops, that's too big. It's outside of 2 pi. Okay, the problem is that doesn't help you as much on this one. If you just divide by 2 and get these 2, you still forget about those. Okay, so that's what you got to be careful of there. All right. Was there another one we were going to look at? I mean, 8 would be basically the same thing. See, on 7, I would say you just take out that negative. Take out that negative. So doesn't this end up just being sine theta equals root 3 over 2? So you take out that negative, then the negatives cancel. And now this one's just going to be erased. This is just going to be easy with that. Now you're going to have pi thirds and pi thirds. Now, if you're having trouble with this part, talk to me. I mean, look, if that's confusing you, or whether it's you're doing unit circle or finding the right reference angle, that's important. I mean, that's obviously you're gonna do all this other stuff, and then you're not gonna be able to get the right answer at the end. And that's the part in calculus we really got to know. We just got to know these angles here. Okay, so that'd be pi thirds and 2 pi thirds for that. All right, so let's take a look at a couple of algebra kind of techniques here. All right, so in your notes would be fine. Where's my book? Here we go. Okay, I had a couple of them I wanted to do here. So we talked about gathering terms together, so let's get one like that. Okay, so 4 cosine x minus 1 equals, let's make that negative 4 cosine x minus 1 equals negative 2 cosine x. Okay, try that one. Solve, let's do 0 to 2 pi. Let's do them between 0 and 2 pi. Solve it between 0 and 2 pi. All right, what do you got? Quick, shout out. 2 pi thirds, 4 pi thirds. Okay, so the simplest ones where you have to do more than just get the simple thing is you just got to group the trig function to one side. So I got everything to the left, I added 2, I got that, I add the 1 over, I get cosine x equals negative 1/2. Cosine x negative 1/2 is over here, pi thirds reference, so it's 2 pi thirds and 4 pi thirds. Okay, all right, what other algebra things could we possibly do? Try this. Now, I'll give you a hint. What would you do if you had the equation x squared equals 9? Right? If you had the equation x squared equals 9, what would you do? Do the same thing to this. Let's see what you come up with. many answers? How many answers? Wrong. How many answers? Good. Good. No. Wrong. How many? We said 2. We said 3. 4. There's 4. There's 4. Now, Jacob, you're shaking your head. Yes. Why did you say 4 right away? You weren't confident. You weren't confident.
That seems like the right way.
What do you do to both sides? When you got x squared equals 9, what do you do? What's the answer? Plus or minus 3. You square root both sides. Plus or minus 3. You square root both sides. You get the plus or minus square root of 1/2. When you do the square root of a fraction, you can do the square root of the top, square root of the bottom, which is square root of 1 over square root of 2. Square root of 1 is just 1, square root of 2, we don't leave it that because we're used to seeing it as square root of 2 over 2. If you multiply top and bottom by radical 2, you get root 2 over 2, which is one of our nice numbers that we know about. And so what is the reference angle for that? Pi force. And what quadrants is it in? 1 and 2 and 3 and 4. The positive root 2 over 2 is in 1 and 2. And sign is negative in 3 and 4. It is in all 4. When you do the square root of both sides, you have to account for all 4 quadrants, the 2 that are positive and the 2 that are negative. And so we have pi force, 3 pi force, 5 pi force, and 7 pi force. Okay? So, that's fine. I mean, I'm throwing these at you and letting you see what they are. You haven't seen that before. Okay? So that's what that one would look like. Okay. So, now we start getting into some things like we did with identities. Okay? So let's say you had this problem. Now think about the work we did with identities. When you see something with 3 terms like this, what comes to mind? FOIL, right? Factoring. Maybe a common factor or something like that, but FOIL. Try that. Try that on this one. How many answers?
3.
Good. Right? 2 sine plus 1, sine minus 1. I think I foiled that, right?
Yeah.
Okay? And then set each one of those equal to 0. right? Said each one of those equal to 0. The first one you're going to take away 1, divide by 2. So that's going to be negative 1/2. This one you'll add 1, sine equals 1. So on this one, you're going to have a pi 6 reference in the third and fourth quadrants when sine's negative. And on this one, where does sine equal 1? That's up here at pi halves. So 7 pi 6, 11 pi 6, and then pi halves for your answer there. Okay? I think I said one time last week where all of this that we've done, I mean really a lot of it, the graphs, understanding the graphs of sine and cosine and tangent, the identities, memorizing of the unit circle and all of these values has all been because of these kind of problems. I mean, we're in calculus, where you do, I mean, not that you don't need trig for other places too, but when we solve a problem, and we're going to do some of that, maybe we might do one here even after lunch. If we want to solve a problem, kind of a story problem or something like that involves a trig equation, it's going to involve solving the trig equation, having to do the trig equation, and be able to solve it and get these answers. Okay, so all of that comes to being able to factor, do what we did with identities, knowing the unit circle, all that stuff. Even we talked earlier about thinking about the graph and why that's helpful, and we're gonna talk about the graphs with one of our story problems here in a little bit after lunch too. Okay, so give you one to think about. Maybe this can be your conversation table today at lunch. Okay, all right. Now I gotta remember it. I just saw it here. Here it is. 2 sine squared. So write this one down and we'll finish it after lunch. 2 sine squared plus 3 cosine x minus 3 equals 0. 2 sine squared plus 3 cosine minus 3. We'll finish that after lunch. And no fair asking any of the lunch ladies, Dale. You didn't come up with anything? All right, let's do it.
Missed the whole lunch period and I couldn't
Okay.
get it.
All right, let's take a look at this one. So, thoughts? What's different? What's problematic on this one?
There's an example.
Oh, hey. I wonder if I'm still recording. I would think I probably am because I don't remember stopping the recording. Yeah, I am. All right. So anyway, what's problematic?
We have a sine and a cosine.
There's a sine and a cosine. So it looks like we would want to FOIL this, but we can't because the middle term would be sines, not cosines. So thoughts?
You can substitute the two sine squared for negative 2 cosine.
Not quite.
Isn't it?
I did the
Two-
common denominator.
Wait, wouldn't it be 2 cosine or 2 minus 2 cosine?
It'd be 2 minus. In other words, forget the 2. Just leave the 2 set there. Substitute the sine squared and replace it with
Negative cosine.
1 minus cosine squared, or negative cosine squared minus 1. But the problem is the 2 would then have to distribute. So there wouldn't be a 1, there'd be a 2. In other words, make it look like this. Do that. Everybody go ahead and write that down. So, now you got to be careful because we all know that in solving algebra equations, you don't need to write down every single step. There's some of it you can do in your head. Maybe you've done a lot of them, maybe multiple steps you can do in your head. But just be careful doing that because it's easy, like I did earlier today. I lost the negative. I was moving things around and I lost that negative on the radical 2. right? So you could lose things kind of easily. So all I did is I took the sine squared out, and because I was thinking, hey, this would be a FOIL situation if I had a cosine squared here instead of a sine squared. So that's a substitution we can make. So here's where the identities start to merge together with what we're doing here with these equations. Okay, so we can make that substitution, then we can distribute the 2 right there. Now we can kind of combine some terms. Now here's where I did a couple of things in one step at this point. I saw that I would rather have a positive on my squared term when I do FOIL. That's just easier. And I have the 2 and the -3 I can put together to make -1. So all in one step, I'm going to make that a -1, and then I'm going to divide everything by a negative just to get that leading coefficient positive. So that turns this to positive, it turns this to negative, and then the 2 minus 3 is -1, but then that'll turn to positive. And then we get that. Okay, all right, then you go ahead and FOIL that and finish it from there. All right, so if we factor that, I think I've got 2 cosine -1 and cosine -1. Is that what you're looking at? Okay, and so then we set each one of those equal to 0. And so 2 cosine -1 equals 0, cosine -1 equals 0, so cosine is 1/2, cosine is 1. So 2 separate problems to do. Again, we're restricted 0 to 2 pi, let's assume. And so this would be a pi thirds reference in the first and the fourth, since it's cosine, and cosine equals 1. Cosine is the x, of course, in the unit circle, so cosine would be 1 right here. Sometimes this is where you'll get a no solution. For example, maybe at factored you get cosine -2 equals 0. So then you get cosine equals 2, well, you can just throw that factor out. That part will never be 0, only this part. And so you just throw that. The answer is not no solution. It's just this part of the answer, right? So what that means is you've got 2 things multiplied equals 0. That will equal 0 if either one of them is 0. It's possible this one will never be 0. So the answer is only when this one is 0. Okay, so you don't put no solution in. I mean, you could write no solution here and just cross it out, and then your answer would be those 2. But anyway, we end up with 3 answers. 3 answers on that. Okay? All right. Let's look at one more scenario. No, let's save that scenario. Okay, let's do a story problem. So open your book. You're going to have a worksheet here with a handful, and then you're going to have some book problems too today. So let's take a look at page 396. 396, we're going to look at number. Okay, so we're going to look at 89. Okay, so go ahead and read 89 there. On 396. All right, so this would be similar to something that we might have in calculus where you'd be given an equation like this, and then we'd want to do some calculus stuff to it. And we may end up, after we do the calculus stuff, we may end up with an equation like this or something, and then we have to solve it, right? And we have to solve it. And we go to our calculators. The calculators are going to help us so you can get your calculator out on this one. Okay, so why is the displacement from equilibrium? So you've got the thing going back and forth. If it's at rest, we call that 0. Right, and so you can see on the chart here, or on the picture here, if it's stretched past that point, that's the y. So how far it goes past. Now you know what would happen is it would go back up past equilibrium, and then it would come back down, and it would kind of go back and forth, and finally come to rest right there at the 0. So the displacement would be positive 1, would be past when it's stretched past the 0 point. And negative would be when it's up above the 0 point. Okay, so you'd have some positive and some negative to potentially go along with that. It says find the times when the weight is at the point of equilibrium, which means y equals 0. So we would take this equation and we would simply replace the y with a 0, right? So we want to solve this for t. Now, in story problems, almost always we're using radians. Now, unless it's triangle problems. If it's triangle problems, then we could be in degrees. Or if it's something where there's an angle. For example, one we're going to do tomorrow talks about the projectile motion, where it talks about the angle of the object, the arrow or whatever, or the baseball. Then we would be in degrees. But here our t is in time, right? So this is where the advantage of radians come into play. Okay, so it says in the problem that t is between what, 0 and 1, I think. Yeah. So we're going to have this thing going back and forth for, let's say, is it 1 minute or seconds? Does it say? It's seconds. Okay, t is in seconds. So we simply need to solve this. Okay, so let's do it. So let's do some algebra. So what do you want to do first? What do you want to do with this 112? And I wouldn't distribute, but you could. It just makes it a little messier. Can't we just get it out of there? Because what we have is this times this equals 0. So when either this is 0 or this is 0, well, 1/12 is never 0, right? We could times both sides by 12 and it would just go away. So I'm going to just get it out of there. Okay, because we don't even need it. Now you could distribute, and that'd be fine. It's going to work out okay in the end. Okay, now it is a good thing that both of these have 8s inside of them. Okay, that one's not an 8 and one's a 2 or something like that would make this more challenging. Okay, what are we going to do if we have both a sine and a cosine in the problem? Okay, and there's nothing squared, so we can't make a nice substitution, right, like we saw in the last problem. Well, what you usually want to do is get the sine on one side and the cosine on the other. So let's get the sine over to this side. Especially when we don't have something else added on is when this becomes useful. Because now what can I do to both sides here to turn it into one trig function? I can divide both sides by cosine 8t. So this is a strategy you want to keep in mind where you have a sine on one side and a cosine on the other. You can divide by cosine because sine divided by cosine is what? Tangent. So now we have 3 tangent 8t equals, what do we have over here? 1. Now the only problem, and we'll get into this later, the only problem would be, whoops, that's 8t. The only problem is when the bottom is 0. You can't divide by 0, so when would cosine be 0? So we'd have to worry about those kind of situations, but it's not going to be an issue in this problem. So right now, we're not going to consider that. We'll worry about it. Now we divide by the 3. And now is when the calculator would get involved. Okay? Now, problem here is remembering that we have to be in radian mode. Okay? This is not an angle like in a triangle. This isn't like an angle you're shooting or throwing a baseball or shooting a basketball or something like that. If it is, then you could be in degrees. Okay? Here t is time in seconds. It has to be just a real number, like 2 pi is 6.28. Right? In this problem, pi would be pi seconds. 3.14 seconds, okay, is what this would be. All right, so go to your calculator and you're going to type in what? Inverse tan of 1/3. In radians. Make sure you're in radians. What do you get? So what should I write down right here, right now? 8t equals point. Give me about 5 decimal places on that thing. 3 was first. 32.32175. Now, there are other times potentially when tangent could be 0.32175, right? Remember, that's radians right there. That's what I just found right there is radians. Remember, 1 radian is 1 string. 1 string around the circle, 1 radian would be about there. Okay, so this is a pretty small angle, 0.3 radians. Remember, 1 is right there. This is 1.57, right? Pi halves, this is 1.57. This is 3.14 over here. Now, what's the next thing I have to do when I have an 8t in here? I have to go up here, right? Now, I don't divide by 8 yet. I go up here. If t is going to be between 0 and 1, what is 8t? Between 0 and 8. Between 0 and 8. Now, where is 8? How many times around is 8? Careful. How many times around is 8? It's not 4, that's 8 pi. This is 8. Remember, pi is 3.14. 2 pi is 6.28. So it's 1 time around would be 6.28. What did we say this was? Pi halves is 1.57. What's 6.28 plus 1.57? 7.8. So isn't it going to be 1 time around plus here plus just a tiny bit? Okay. So where's my other reference angle in this one? This was tangent here. So I have 0.32175. Where's the other one? Third quadrant. Also 0.321 something, right? Come on now, it's the same thing we've been doing. We get to here, we get to here, we figure out what angle this should be. Now usually we just have it memorized. We let the calculator find it for us. It gave us 0.32175. So we got to also be in the third quadrant, but now we're restricted to 0 to 8. So that means 1 time around 6.28 plus another time around 7.8 something, and then 8 would be to here. How many answers does it look like we're going to have? 3. 1 time around is going to give me 2, and then I go up through the first quadrant again. That's going to give me another one, and then I would stop. And 8's going to be up in here somewhere, and that's where I would stop. Okay, so I need to write all these down. So I got 0.32175. What's this second one going to be?
3.4617.
Pi plus, so use your pi button. It's going to be pi plus 0.32175. What was that again, Charlie? 3.4634. And then what's this last, the third one going to be? It's going to be all the way around, which is 2 pi, right? Well, it'd just be plus pi again, that's true. Or you could start over and you'd say it's 2 pi, so you could do 2 times pi button plus 0.32175. Now what's that? 6.605 something. Now what do we have to do with all three of those?
Divide them by 8.
Now we divide them by 8. Now we divide those all by 8, and they're all going to be between 0 and 1 that way, right? Which is what we want. So our t is going to be, what's the first one?
0.0402.
Okay. The next one, 3.4634 divided by 8.
0.4123.
And what's the 6.605 divided by 8?
0.8256.
Now, it's easy to get lost in the weeds here and forget what we were trying to accomplish. What did we just find? What did we just find?
Where it's at equilibrium.
We pulled down on this weight. It was bouncing back and forth. In 1 second, it was back at the 0 point, the equilibrium point, how many times? 3 times. We pulled it down, right? We let it, I don't know what it said in the thing. It says a weight is oscillating, okay? It's just, where y is a displacement, okay? So we just pulled it down, let it go. It was at the equilibrium point, it passed it going this way, and then came back down, passed it again, came back up, passed it again. It hit it 3 times in the time period 0 to 1. Okay? So the calculator can help us if it's not, the only reason the calculator helped us is it wasn't one of our special angles right here. Like if this would have been tangent equals root 3, then we would have found one of our special angles. But if it's not, we just let calculator find the angle. We did it in radian this time instead of degrees, but we still drew it in the same quadrants. We still had to make the same calculation based on this, okay? And we solve it, and we get that, okay? All right, so that's what we would like to do with that. We're not going to do a lot of that on the quiz on Friday, but there could be at least one. We'll do another one tomorrow, probably do another one on Thursday, just so you see it. But you're given the equation. So it's just a matter of solving it using whatever strategies we've been practicing to get those together. Okay, so back to kind of some simpler ones here. We'll do some, these are, I think these are all no calculator. I think these come out kind of nice. There's a little mixture. There's some of the multiple angle ones like the 8T or something in there, so we got to keep doing that a little bit. But basically this worksheet is just ones where you just have to rearrange terms to get the trig function by itself. Then I'm going to add a few from the book, which get into mixing in some factoring and some things like that. So if you want to write on the back maybe of this worksheet, on the back of the worksheet, page 394, let's do, let's say 19 through 31. Odd, those are odd. 19 through 31 odd, page 394. Okay, and you can do those on the back of the worksheet. Okay, you can work the rest of it.
this by 4, does it divide that one 4 and that one?
No.
Just
Not
the
the
outside?
inside, yeah.
Okay.
Yeah, question here. Notice, well, I didn't really do it, but, right here. So when we divided both sides by 3, everybody look up here just a second. When I divide both sides by 3 here, the 3's on the outside of this. That doesn't affect this 8 in here. We can't divide that 8 out of there because it's inside of the tangent. Okay? Not until we do the inverse tangent of both sides, get rid of the tangent, do we mess with that 8. So when we say divide by 3, we're dividing by that 3. It doesn't affect anything on the inside, okay, of that function. And I wish the worksheet had parentheses around the theta, like when you have the 2 theta and the negative 2 theta. And if for me doing this worksheet, I would put those in there. I would put those parentheses in there.